Today we're going to look at the mathematics behind World War II, specifically the Enigma machine. So let's just start out with a basic background of World War II. World War II was a very long war. We know that it took place from 1939 to 1945. This was a worldwide war. The conflict was spread all over the entire world, and the people that were involved in this war were the Allies that primarily fought against Germany and Japan, and the United States, were part of the Allies. That also included Great Britain, China, and the Soviet Union, who made up the Allies, and that was the group fighting against the Axis. And Japan and Italy formed the coalition called the Axis powers. Later in time, Bulgaria, Hungary, Romania, Croatia, and Slovakia eventually joined them. So where was this war involving so many countries fought? Predominantly it was fought across the entirety of Europe, Asia, and also in Africa. So how did a war of this magnitude really happen? So after World War I, countries and their economies were truly devastated. Although European economy was said to have stabilized by the 1920s, the totally different event that was happening over in the United States that we know as the Great Depression led to actually an economic downfall in Europe. So communism and fascism gained strength in the wake of these economic problems. Also, an extreme form of patriotism was apparent in Europe. It became even stronger after World War I, especially for those countries that were defeated in World War I. So let's dive a little bit deeper into the mathematic machine that was an apparent figure within World War II. This is known as the Enigma machine. The inventor, Arthur Sherbrius, was an inventor of this object that looks similar to a typewriter, but you'll soon find out is much more complex than that. It was heavily used with communications for World War I, especially those communications that were top secret by the Germans. It is used by an operator to create scrambled messages. The importance is behind the receiver being able to understand those messages. The Enigma machine allowed an operator to type in a message. Then it would be scrambled using the 3 to 5 notched wheels, or rotors as they'll be referred to, which displayed different letters of the alphabet. The receiver, it was ideal and incredibly important for them to know the exact setting of the rotors in order to create the decoded text. So in time and over the years, this machine got even more complex, and by the time the Germans got their hands on it and were using it for manipulation within war and to pass along messages, they added complexity to this machine, and it required for us to bring in some serious math minds in order to decode this message. Especially the Germans, thinking that this was a message that was not able to be code broken. This was a huge advancement for the Allies. So the machine was composed by an algorithm, and it used electronic circuits or currents to randomize the inputs. So every letter had a letter assigned to it. So you'd push a P, and that would actually mean a V. So if that letter, say the P, was pressed again, the coded letter would change. So if you push that letter again, it would actually be a coded letter for a different letter, which just proves the complexity to this awesome machine. World Science Festival created this video so you can see in a little bit more specifics how the machine really works to better understand it.
Right here, if I type in the letter P, let's see what happens. The letter E lights up. So P is encrypted as an E. But what's really clever about the Enigma is if I type in an E again, a P again, a V lights up. If I type in P again, a Y lights up. So we have a random letter generator. The encryption doesn't seem to follow any kind of pattern. And if you want a good form of encryption, that's what you need, a kind of random letter generator. So
This video gave you a little bit of better understanding how complex the Enigma machine really is and how it might work. If you want to watch this video further, there again will be a link at the end of the video to watch this video. So we have this incredibly difficult machine to code break, and who's going to be able to break a code that is so complex and being changed each day by the Germans? That's when we brought in mathematic mastermind Alan Turing. He was an incredibly intelligent mathematician, and he focused his efforts to crack the secure Enigma code. The Germans changed the cipher system daily, so it made understanding the code even more difficult. So he and Gordon Welchman created the bomb to be able to quickly and easily code break the codes. This was just one of Alan's many advancements that he made by that was used to encode. So now I'll show you a video that describes the math that is behind a machine that is used to understand the Enigma machine.
Would rattle around, and this would help you break the code under 20 minutes. So you would have to break the code every morning. So every morning the settings for the Enigma machine would change. So all the Enigma machines would change, stroke of midnight. So that's why a machine that could break the code that quickly was so important. So the bomb machine tried to work out the plug board at the front of the Enigma machine. If you go back, at the front of the Enigma machine, you have this thing called the plug board that connects letters into pairs. You actually make 10 pairs of letters. When I press a letter, the signal first goes through the plug board. It then goes through the first rotor, through the second rotor, through the third rotor, it then loops back, and it goes through the machine again in reverse order. So then it goes through the third rotor, the second rotor, first rotor, and finally it goes through the plug board one more time, and it lights up one of these balls. Now I'm going to try and draw that for you, but I'm going to make it as simple as I can. Let's try and do that.
So now number 5 will go ahead with his video and show even more how the math could be written out to understand this machine. I think this video is a great example to show math coming to life in this machine and how math really plays a role in this complex machine.
First of all, it goes through the plug board, and it goes through all the rotors, and I'm going to call that just one big magic box called R for rotors. And the last thing it does is it goes through the plug board. If we look at our weather report here, let's look in the second one. T becomes T. When you do that, if I press T, it goes through the plug board, through all the rotors, through the plug board again, and out comes T. Now we're going to use this to work out the plug board. I'm going to make one guess. I'm going to guess.
Again, if you'd like to watch this video further, we just watched a little part of it. The link will be included at the end of this video. So what sort of impact did the Enigma machine have? In general, it was a huge advancement in technology, especially in encryption. The mathematic advancement helped to decode these top secret messages that contributed to the end of the war. And it was said to have saved millions of people's lives by bringing an end and closure to this war. These Allied forces could get ahead of the German plans, and it really gave us a leg up within World War II. So we can confidently say that mathematics and the major math minds behind code breaking of the Enigma machine affected the outcome of the war and gave the Allies a huge upper hand, which contributed to our win in World War. So who knew math could have such an impact on history? The Enigma machine is a great example of how math really was a forefront and an upper hand within the war and changed our entire history. If you'd like to further research this machine and any of the history behind it, please feel free to use the sources that I used to create this video, which are shown here. And if you are interested in to continue watching either of the videos that were shown, both of the links are provided, and some useful sources that I found were really interesting for the Enigma machine. The video was interesting to you and that it also challenged your mindset that you had before about the mathematics behind World War II. Thank you.